두렵기도 하지만 노력은 우리에게 정답이 아니라서 마지막 선물은 산뜻한 안녕. 저기 사라진 별의 자리 아스라이 하얀 빛 한동안은 꺼내볼 수 있을 거야. 아낌없이 반짝인 시간은 조금씩 흩어져 가더라도 너는 맘에 살아 숨 쉴 테니 여긴 서로의 끝이 아닌 새로운 길 목표에 익숙함에 진심을 속이지 말자. 하나 둘 추억이 떠오르면 많이 많이 그리워할 거야. 걸었어요. 그래도 이제는 사건의 지평선 너머로 저기 사라진 별의 자리 아스라이 하얀 빛 한동안은 꺼내볼 수 있을 거야. 아낌없이 반짝인 시간은 조금씩 곁어져 가더라도 너는 맘에 살아 숨 쉴 테니 여긴 서로의 끝이 아닌 새로운 길 목표에 익숙함에 진심을 속이지 말자. 하나 둘 추억이 떠오르면 많이 많이 그리워할 거야. 걸었어요. 그래도 이제는 사건의 지평선 너머로 사건의 지평선 너머로
Shut up.
But we're sitting free. But we can litter on the street.
Good evening, and thank you for the quacking across the sofa. So last session we reached the end of TIS-100, in which we discovered precisely what it was that had eaten Randy's brain. Well, okay, we didn't really. We got a brief glimpse of what it was that had eaten Randy's brain. But then our TIS-100 rebooted, and we found, well, I mean, it had been there already, the TIS-net directory, which appears to have another 25 levels for us to investigate. In particular, Simon was muttering about merge sorts, and we appear to have a sequence merger, a sequence mode calculator. I'm not entirely sure I've actually finished all of these ever, so we'll see how it goes. So let us visit. So the first ones were just called segment followed by a number. This is Nexus 00.526.6 sequence merger. Create new program. The clonks from the game may be a little different from usual because it's not on the television, it's on my laptop, because there's no one here who's actually attentive enough to want to be able to read my assembly language. They just want to go quack. See? I couldn't possibly comment on whether my brain is entirely eaten. Right, so we still seem to have notes in the unhappy cells, which are still turning up in green for you so that you can read them. They're red for me as a reminder. Hi, who is this? Is this a prank? Not as far as I can tell. How? This isn't hooked up to anything. Not sure. I think it communicates wirelessly. Don't be ridiculous. I'm Carol. Hi, Carol. I'm Mosley. Puzzle submitted by Johnson E. So yes, this is clearly the extra puzzles provided by foolish players of the game who have got through all of the earlier ones. So what are we doing? Sequences are zero terminated. Read a sorted sequence from in.A. It really is a merge sort, well, one step of a merge sort. Read a sorted sequence from in.B. Merge the sequences into a sorted sequence and write it to out. And while it doesn't say it at the bottom, repeat for multiple sequences. So this, of course, has the annoying feature that the sequences want to be in ascending order, but we kind of want to treat 0 as the last possible thing in a sequence. But we can't actually start merging until we get to here. So if there's any pre-processing we can do on these, on the incoming data, then that would not be a completely terrible idea. Like, maybe no, negating them all doesn't help. That just means we end up constructing the sequence in the wrong direction. Because kind of I want 0 to be what terminates the sequence, but on the other hand, I don't want to have to muck around changing treating it specially for comparison purposes. But maybe I do something like, if the value is non-zero, then offset it so that it's hugely negative, then do all the sorting, then put it back again. Like, our sequences do, after all seem to be positive, so we could probably assume they're all positive. So if we do that, then that will shift all of the sequences downwards so that 0 is the highest possible value, the largest possible value, rather than the smallest possible one, which will then mean that it naturally ends up at the end of each sequence, which seems like it should make life easier. So two zeros, and yes, I'll have to ditch one of those. And there's our reversing the transformation operation. So this feels to me like we need, because the thing is, we might need to see this node that's going to do the comparison will have to see each value repeatedly until it's needed, essentially. So it needs some way of signalling back to, maybe these ones keep working out which value we're currently thinking about, because you can't in particular can't just compare ACK and BACK, or indeed ACK and QUACK. Yes. So we have to be a bit more clever. So I mean, the we obviously start then by doing this, and then we want some kind of write one of them first, Ben. Is that sensible? Probably not quite. I mean, I suppose the trivial version actually goes like, so we have two operations. One is send me the last number again, and the other is actually send me a new number. And I'm not sure that's going to be the best approach. I think actually what I'm going to want to do is to code the middle thing and see what primitive operation in merge sort. It's see which of our two neighbours is smallest, and then copy that to the output. Be consistent about your commas, Ben. So that's the obvious kind of yeah, I'm totally going to need to change what the operations are, aren't I? That's the obvious compare things, and then if the result is greater than 0, then that means that left was smaller and otherwise right is smaller. So if left is smaller, then we need to go so I definitely need to simplify this. So let's see, what do I actually want? Because I've got far too much signalling to the neighbouring processors at the moment. That's obviously not appropriate. And the neighbouring processors can afford to be quite complicated compared to what they currently are. So the middle one should actually do something like so it wants to essentially request a number for each side, and then from one side it will ask for that number again so that it can pass it on, at which point that side should then not give us anything more, and from the other side it will not ask for that number, and then it will ask for a number from both sides again. So our our operations in these things are send next number and send the current value of the accumulator and send the current value of the accumulator and then advance. So that's kind of inconvenient for the way that Simon suggests take away the number you first thought of,
All of them.
which I'm not sure he's intending me to take seriously. But it is an intriguing possibility, actually. I wonder if I can avoid the need to tell... No, I still need to tell one processor that I have processed its number now, don't I? So I don't think that helps me. I was wondering if I could always request a number from the same side and use the fact that the accumulator is the difference in order to fabricate whichever one I needed by making it a mov or an add. Or a sub, depending. But actually, I don't think that helps me because that's just going to make my life even more confusing. Let's do the relatively simple version first. So my two operations are actually mov ac write and mov ac write mov up ac. But we may need to do some initialization mov up ac in order to make sure that we start with a number ready to be sent on. And there may need to be some outer loop that resets all of this in the case where we when we finish a list. I'm not really dealing with the finishing a list process yet. So now we don't need that silly initialization code. Sorry, I should stop wittering in IRC. Right, so instead we do. So we still currently have a mechanism whereby we have to signal. We have to signal that we want a number from each side, but I think that's actually we want maybe these processors should actually do the whole of 3 each time, in which case I'm just going to go. I bet we can do that. Yeah, we could do that without having to engage in such silly buggers. We just move that section up to there, and it then becomes -3. Only then we can remove that jump and it becomes -2. That's much more sensible. So now we start by sending a number into the center because we know it's always going to want a number at the start. So then the center can just start with mov left back sub right, Then, so if it is now, so if the result is greater than 0, then I seem to have got confused while I was writing this because my left and right have got an odd way round. If we take left, we subtract right from it. If the answer is greater than 0, that means right was smaller. So I think it's only the naming of that label that I got wrong. So if it's... So if we want to send left, then we move 1 left and then mov left down, I think. So that gets us... No, we mov -2 left. We say that we are now consuming this for the final time. Okay, there's still a bug here, yes. I'll fix it later. So we then say we want this and we're sending it for the final time. Mov left down, then signal right that we want its number, but we don't want it to throw it away and get a new one. And then we jump back to the top. Why did I write R there? That's a completely silly thing to do. Right. That's what I meant to call R. Thank you. Right. And then this time we do the same thing, but the other way around. Mov -2 right, mov right down, mov 1 left. So that's close to being right. The only slight problem is that we need to start these up correctly because at the moment they don't. That I've actually got this the wrong way around again, haven't I? Stoke face. That one wants to go there. That one wants to be part of the startup sequence. But actually before that we want the other part of the startup sequence, which is mov up ac. Unless of course we can loop this around. Hang on, no, I've got this wrong again. So we start by mov up ac. Obviously, we have to start there. We know that we're going to have to send ac to the right. That point we expect to get a request from the right which will tell us what to do next. One of the options is that it has successfully consumed a number and would like us to that it is about to consume a number from us and then would like us to fetch and send it another one. And that's the position we currently call -2, though it's not really appropriate. So in that case, we send ac to the right, and then we loop back to the top, mov up ac, mov ac right. Alternatively, we loop back to here, which is currently called 1, though it's not really 1. We just mov ac to the right. Okay. And then we replace those with the correct numbers, so 1 should become -1. And -2 should become 1.
One of the strangest Spice Girls songs.
Right, maybe that will do the job. I haven't even tried running this yet. Right. Let's try single stepping this and seeing what it does. Like, do any of these processes do what I think they do? Well, they've successfully loaded the first number from each sequence. That's a good start.
This thing has numbers on it.
Well, this one has numbers on it.
So that's good. Correct first number output. Right. I think there may be a certain amount of wanting to adjust the timings here. I think things are not quite ideal, but... Right, we've successfully transmitted the entirety of the first list. Unfortunately, nothing knows that it needs to do anything special when it's transmitted the entirety of the first list. Yes, I'm not sure I've managed to write a merge sort that correctly on the first attempt before. Like, and I've done it in much higher level. I've done it worse in much higher level programming languages. Right. So there was a bit of things aren't quite happening in the right order that I thought I could probably optimize. We always fetch from the left first, so we should probably also signal to the left first so that it can, so that it's always ready for us. That I don't think is a very controversial change to the code. So I don't think that will make change. Let's just test it, but I don't think that will change how anything works. Yes. So then what we need is all of the processors to recognize they've reached the end of the sequence and do whatever is the appropriate thing when they've reached the end of the sequence. So these ones I think can't detect when they reach the end, can't themselves do anything special at the end of the sequence, because the whole point is that one of them will sit there repeatedly returning 0 until the other one is ready. So it has to be this processor that works out that works out when the sequence has ended, which is kind of fiddly because it has to be like, are both sides 0? And how do I do that nicely? Can I, it's like, after, obviously one of the features of both sides being 0 is that the difference between them is 0. But I'm fairly sure we're not guaranteed that the two sequences won't ever have the same number on in both of them. Though the example we've got here, the only numbers shared between the two sequences are the 0s. So, like, we could do a really grotty maneuver of, right, what do we do at the end? So if we reach here, we, for now, assume that that means that both sides were 0. Which means that they both need to be asked to load a new number. And now we haven't really got enough time. No, I mean Mov 1. Hang on, we can be cleverer. So there we say, leftmost processor, give us your number and then load a new one. And then we throw it away. And then we jump to the code we already have for getting the rightmost processor to do that. Right. That looks pretty good. Does depend on the sequences never having duplicates between the two sequences. Because if they do, then we'll treat that as the end of the sequence. Right, that worked. Hooray! Seems to have been a pretty good solution as well. And we can see that this one didn't have very much idle time left. Just wondering if there's a clever way I could have dealt with this without doing what I did, but I can't think of one. It'll do. So, sequence merger, nominal. Next, Nexus 01.874.8, integer series calculator. Interestingly, bimodal cycle count and indeed node count. Graph. 2 dead nodes, one of which has some oddities in it. Where are you, Carol? North Carolina. I'm a professor. I see. You? Denmark. Copenhagen? Yeah. Yes, Diziot, you are quite right. Shall we see if we can do that? Diziot says you could have tested the output number. Yes, thank you for at least 2 desperate attempts to work out a joke along the lines of, no, she went of her own accord.
Copenhagen, you should instead go for our house in the middle of our street.
So the problem with testing the output number is that it doesn't usually end up anywhere I can see. But that's not actually very difficult to work around. Let's see if we can do this. So we would instead use the code we've got already, but where it currently does mov thing down, we would change it to mov thing ack.
Alright, Newt, I'll probably be up at lunchtime tomorrow.
Oh, you're right. Yes. Whenever I output a 0, it will come from the same place, won't it? So I don't have to carefully merge these two streams, because it's guaranteed. Because I only move from the right when the things are different, I will take this path when they're the same. Rather annoyingly, it's guaranteed that it has to be the thing at the top that does the same case. So we could have this case do mov left ac. Let's remove the old recovery code. So then that's the code for the normal case. In the case where, hang on, we're still going to want to send it down, aren't we? Move that up to there. So then if we have just centered so we've already told left that it should reload, it should load the next number. Now all we have to do is tell right that it should reload the next number. Obviously we're thus going to need a jump T there. And then but then it's going to send us something, so we still need to do mov right nil. Except that we could be cleverer than that. I mean, that I think will work. Let's test that, but I think there's a cleverer technique still. So that one is now correct and doesn't depend on not getting duplicates across the two sequences. Thank you, Diziet. I think we can actually make this slightly less full of stuff, partly by virtue of my previous optimization, because if we put the label Z here, then it will almost do the right thing, except, as Simon noted, we'll end up with duplicate zeros in the output, I think.
Marvel pink SKA shirt.
That's very pink.
It is, isn't it? Squawk.
So that worked correctly, except that it duplicated the zeros in the output, as Simon said it would. And then precisely, Simon, the bottom processor discards the second zero, because it has loads of time to do that, and even conditionalizes things on that. I mean, it's slightly awkward because we then have to have an extra jump here, but yeah. Right. Well, okay, I've screwed that up already. What? You got those instructions in the wrong order. Right, there we are. That's almost satisfying. Like now we're not bumping up against the instruction count limit in any of our processors. Right, so where were we? I hadn't actually read the spec for this one yet. Read a value from in, sum all the integers from 1 to the value, write the sum to out. I mean, this feels like it isn't really a job that we should do just by adding numbers together, though obviously we can. Like, there's a really obvious, really dumb brute force approach to this. That's not quite right, is it? Hang on, what am I doing? I've forgotten what I wanted to change something. I want to... go around this loop. I mean, the obvious one was JNZL, but the problem with that is that I really want the 0 to be visible down here. Except I can't do that because I have to, like, swap. Oh, irritatingly complicated. And then I just need to get this loop so that it actually emits a 0 at the end. Does it emit the 0 twice? Yes. Right, so that's horrific, but may possibly be able to give the right answer. Possibly now we should throw at least a small amount of maths at this problem.
Nine.
But the thing is, we can't use the multiplier that we had before because, yes, our multiplier depended on having, among other things, 2 entire stack memory nodes.
Memory nodes.
For stacks. Well, let's hit fast and prove that it can give the correct answer eventually. Right. Well, we've hit one of the modes. We've hit the brute force mode of the cycle count statistics, and the Well, at least you didn't use very many nodes mode of the cycle count statistics. Because apparently there is a solution that involves using that involves using 9 nodes. And is much faster. Actually, so I think we already have a capital sigma. We're trying to be... Yes, what we want is... to be able to do multiplication, but that's kind of... I mean, we already... as far as we knew, we only have multiplication by... when n as an input, turn it into... n minus 1, and then subtract 2 each time. So I sum n plus n minus 1 plus... Right, yes. So rather than sending n down each time, I send n copies of 2n minus 1, or rather I send... n over 2 copies of 2n minus 1, plus an awkward term at the end. Oh, cute, yes, okay. Because, of course, the 0, yes, we can count from 0 or 1, and it doesn't really matter. So let's make our let's completely wipe out the this version of the program. So we could have the first processor go... So this wants to... Hang on, no, I think I'm thinking of something that's a hybrid of Simon's idea and Jacob's idea. So I don't think we add n plus n minus 1. I think we do n plus 1 or 0 and n minus 1 plus 1 and n minus 2 plus 2, i.e. we do n over 2. Oh, we don't have division though. Oh, but we can do the counting by 2s in order to fake division. So that just means we go... I'm going to do the JRO trick again. Yes. Nonetheless, yeah, I think I know what I'm playing at now. hang on. Now let me think about this. No, we want our two operations are load a new value and send our current value downwards. This one's operations are then, so this will make slightly more complex things slightly more complicated. Reset and accumulate, and then this one actually thus needs to send those instructions. So when this one loads a new value, it should also signal downwards that the lower one should send things, and otherwise it should do that. Right, then this one wants to, at startup, send, okay, if it's sending the accumulator down, it'll need to do, no, that's fine. Then its loop goes, but it needs to send an instruction first, doesn't it? It needs to send, no, it doesn't. Yes, so it should send that to say, I'm about to send you no, that's wrong. It doesn't need to do that. Oh, hang on. What's going on here? What are my two instructions? They are... Yes, load a new thing into the accumulator. So that's what we do first. We send one and then we send the initial accumulator. Then we repeatedly send... fours down, subtracting 2 each time, and going to L if we haven't yet run out. Now that's, I've almost certainly got an off by several error. Let's see if we've got an off by anything consistent error indeed, or if it even, yes, it just crashes. Excellent. Oh no, it doesn't. It just outputs completely the wrong answers. Though if you look, that's mostly because it emits a 0 right at the start, which it shouldn't, because there's a slight how does everything start up question, which doesn't quite work correctly, because at the start, this one will signal to this one that it needs to shovel one thing out, which it, in order to, or rather, this one will say to this one that you need to start a new sequence, which means this one will signal to this one that it needs to finish the old sequence. So this one needs on the first pass to not actually finish the old sequence, which we can just do by going mov up nil, which sadly means we're then going to have to add a jump t there. Right, this will still give the wrong answers, But at least each wrong answer now corresponds with an obvious correct answer. Okay, I'm now slightly alarmed by the fact that it started giving correct answers. Okay, no, that was just coincidence. I bet that means it gives correct answers for odd inputs and not for even inputs. So that means that all we need to do is, like, its outputs were coming out too low. Let's just try and add 1 there. No, now the outputs are coming out too high. That's intriguing. So, what's going wrong here then? So for 10, for instance, we can't I can't just get away with Simon's and one of them will get added to 0, because of course we do need 10 needs to end up being a bunch of 10s and a 5. Which is kind of inconvenient. So we do... I don't know how to divide by 2. Well, you're going to have to have an entire separate dividing by 2 system to sort out that odd row. Sadly, it won't give us a timing, so I can't even see how much better we're doing. So... Because, I mean, we can obviously tell whether we had an odd or even input when we get down to here. And see whether our result is 1 or 0. But the problem then is, how do we add half of... I mean, I suppose, though it'll burn an awful lot of time, we can divide by 2 while we're counting down. So we each time... So we could have a processor that just accumulates 1 each time this one steps down by 1. And then at the end... and then at the end we check, it then gets told whether we had an odd or an even input, and then whether it should produce a 1 or a 0. I mean, no, sorry, an n over 2, which it's accumulated itself, or a 0. So here is our leftover half line coprocessor. So its operations are add 1. That's almost certainly the one we want right at the end, but still. And then go back to the top. Or if we've reached the end and the result was even, i.e. we've actually hit 0 there, probably. If, on the other hand, it was odd, we move the current accumulator down. So then this one then signals rightwards every time we want to do any addition. And then if we fall through here, we can probably, oh gods, can we pull off? No, it's kind of doing what Jacob suggested, but not by actually counting from n downwards and from 1 upwards, because it takes advantage of the fact that we know that n minus thing plus thing must equal n. And so the only problem is what we end up with, so we don't ever actually calculate all of those intermediate values. Though possibly we could. Let me finish this version first and then we can try a different one. So at this point, well, let's immediately try the lazy thing and pretend every number is even and check if we can get the right answer for even numbers. I think actually it's adding up n over 2 copies of n, which like shouldn't produce the right answer unless my rounding goes wrong. But let's just test this, and then we'll work out where it's all going. So right, it's crashing. Excellent. So this one thinks it's sending something down, and that one is waiting for that one is waiting for that one. Because hang on, what's going on here? Now that looks reasonable. Oh no, I've got... This is just that I've got that addition happening in completely the wrong place. It's this one that actually does the accumulation. I'd forgotten how primitive the things happening in each of these processes were. Right, so now we can get the correct result for even inputs and not for odd inputs. So now we just have to be a bit cleverer here. So let's actually... Is there a... well, we'll just step through it. 28 times, maybe not. So obviously this ends up with 0 if the input was even, and -1 if the input was odd. So ideally we would then want it to send to the right 2 if the input is even and 1 if the input is odd. So we just have to add 2 and then mov ac right. Right, and now it's correct. Still not particularly fast, mind. And like we have an entire processor dedicated to the job of dividing numbers by 2 and adding them when necessary. So then, of course, there's the question of could we do Simon's thing of n over 2 copies of n plus 1 versus n over 2 copies of n for suitably rounded versions of n over 2. In the even and odd cases. But the problem here is that we only really get to discover whether it's even or odd right at the end. And by then we've already done all the additions, so I don't think we can. What? You've stopped? Crashed? I'm confused. Let's let it run at normals, but actually no, let's hit fast and see what happens. So it works fine, and then jams right at the end. Oh, because I've written this so efficiently, it doesn't actually... No, it insists on knowing... Yeah, let's just slightly change the order in which this happens so that it doesn't insist on reading a value off the end of the input array before it'll output the last value. No, that still doesn't work. I think we need to do the same thing here. Oh, I think I've just discovered a new key. I think Control and the arrow keys moves you around between processors. How useful. That's better. Right, we're now down at least vaguely in the leftward peak of the cycle count statistics. It's still not good. But it is at least a good deal faster. So it looks as though there are versions that use fewer instructions, and indeed fewer cycles, though obviously not fewer nodes than we've achieved. So yes, we've accomplished 2 out of the 25 additional levels. I don't think I can fit in another one before midnight. Roll by more than 2, then you could spot when your value goes negative and feed it straight to a JRO that then makes another processor add the right compensation value. Possibly. I think that's probably too difficult for me at this time of night. So I mean, I'm now beginning to feel like we could, like there's something that involves making use of more processors by having different ones do different bits of the computation. Like if you imagine having one thing that did subtracting 4 each time, and then another thing that got the results from that and the remainder, and then did subtracting 2s, and then passed on the result and the remainder. No, I don't think I can accomplish that at 10 to midnight. And I don't think I'm going to attempt the sequence range limiter tonight. I think I'm going to declare that that's enough for one day. And we might be back on Friday, or maybe Verity will be up to playing some Crusader Kings again by then. We will see. But for now, good night.